Welcome to qnawire.
In this example, I'm going to be using Kirchhoff's laws to find the current in a circuit. So first, let me draw the circuit we'll be working with. Okay, so we have a simple circuit. We have two resistors, 7 ohms, 5 ohms. We have 3 power supplies. We have a 4 volt here, 6 volts there, 8 volts there. And I want to find the currents I1 in that direction, I2, and I3. All right, so Kirchhoff's laws, what do those tell us? They tell us that the current into the junction has to equal the current out. So here I'll choose to look at point B. You can choose any point, or that's actually no, we only have 2 nodes here. So we have A or B. I've chosen B. You can choose A if you wish. But this tells me that the current in equals the current out. I have 3 currents coming in, 0 current going out. So that gives me at point B, I1 plus I2 plus I3 equals 0. All right, this is a good start, but we still need some more information. And for that, I need Kirchhoff's loop law, which tells us that around a closed loop, so say going from A, B, D back to A, from A, C, B back to A, or A, B, C, A, or A, D, B, A, that total change in potential is going to be equal to 0. All right, so I'm going to look at this loop here. I'm going to look going from A to D to B back to A. I want my total potential change to be 0. All right, so delta V equals 0. Now let's look at our individual components. Starting here, I have I1 going across my 7 ohm resistor, so that's going to be a negative 7 because the voltage is dropping times I1. All right, so that's through there to point D. All right, then we need to add 6 volts because we have a potential increase of 6 volts. Same thing up here, we're going to have a potential increase of 4 volts. So plus 6 volt increase plus our 4 volt increase equals 0. From that, we can say negative 7 ohms times I1 equals negative 10 volts, or I1 equals 1.43 amperes. All right, and I'm going to do something similar to find the second current, I2. All right, we have, and let's see, I'll be using loop. Let's do A, C, B back to A. So we have 5 times I2. It's going to be negative again because there's a drop. So we have negative 5 ohms I2 plus my 8 volts now plus my 4 volts equals 0. All right, we see I2 times 5 plus our 8 volts plus 4 volts back to get back to point A. That gives us a value for I2 equals negative 12 volts divided by 5 ohms gives me a current of 2.4 amperes. Right, and to find I3, I want to go back to my node law where we stated before I1 plus I2 plus I3 equals 0. All right, so I3, which is what we're looking for, our last current, equals negative I1 plus I2 equals negative 2.4 amperes, not ohms. Sorry, I got my units confused. Amperes 2 plus, what did I say I1 was? 1.43. 1.43 amps, which gives me I3 equals negative 3.83 amperes. Okay. Right, and that's how you use the loop laws to solve simple circuits.